Your furnace just died. Not because it's broken, because the power grid failed and it needs electricity to run the blower. Ignition, thermostat. No power, no heat. Your backup plan is the fireplace, right? Wrong. That fireplace sends 80% of its heat straight up the chimney. You're burning wood to heat the sky. Meanwhile, it's the middle of winter during World War III. Supply chains collapsed. No propane delivery. No fuel oil truck. No firewood for sale because everyone else figured out the same math you did. You've got what's in your shed. When that runs out, you freeze. Hypothermia kills in 24 hours at 10 Celsius. But here's what they don't teach you. There are 3 technologies that let you heat your home with almost nothing. No grid, no deliveries, just physics. They're not classified. They're just ignored. And the reason why should make you angry. Let's start with the heating method. That's illegal nowhere, but taught nowhere. You think your fireplace is a survival tool. It's not. It's a heat exporter. Here's what the hearth industry doesn't advertise. A conventional fireplace loses 80 to 90% of its heat straight up the chimney. You're not heating your home. You're heating the atmosphere. The draft that makes the fire burn is the same system stealing your BTUs. Hot air rises, cold air gets pulled in through gaps around doors and windows. You're creating a convection current that treats your living room like a chimney. If you've got good draft, you're actually making the room colder because you're pulling in outside air faster than the flames can warm it. Furnaces aren't better. A gas or oil furnace needs electricity for the blower motor, electronic ignition, circuit boards. No power, no heat. Without the blower, heated air sits in the heat exchanger, and the system shuts down. You've got a 200-pound paperweight in your basement, but even if everything worked, you're still losing. Conventional wood burning is an energy density disaster. You load a log, it burns hot for 20 minutes, coals for an hour, then ash. Heat spike, then slow decline. To maintain temperature, you're feeding the fire every hour through the night. A family burning wood, conventionally, will go through 1 to 2 cords per month in cold climate. That's 128 to 256 cubic feet. Most of that energy leaves through the chimney. There's a different approach. It's called a rocket mass heater. It doesn't just burn wood differently. It stores heat differently. The design uses 2 principles: complete combustion and thermal mass. Here's how it works. The firebox is a J-shaped tube. Horizontal feed at bottom, vertical burn chamber above. You load small diameter wood, sticks, branches, scraps. The J-tube creates intense draft and high oxygen flow. The fire burns at 900 to 1100 degrees Celsius. At that temperature, you're not just burning wood, you're burning the smoke. The gases that would escape as creosote and particulates combust. The exhaust is nearly invisible. But here's where it gets interesting. That exhaust doesn't go up a chimney. It routes horizontally through a mass of cob, brick, stone, or clay. The mass absorbs the heat over hours. Then it radiates that heat back into the room for 12 to 24 hours after the fire dies. You burn a small fire once or twice daily. The mass does the rest. One firing heats your space for a full day and night. Now let me show you why this technology has been sitting in permaculture forums for 40 years instead of every suburban basement. The efficiency isn't just better. It's categorically different. A conventional wood stove operates at 60 to 70% efficiency at best. Most of the time, closer to 40 or 50% because of incomplete combustion and heat loss. A rocket mass heater runs at 80 to 90% efficiency. The secret isn't hotter fire, it's complete fire. In a conventional stove, wood burns at 600 to 800 degrees Celsius. Partial combustion. The wood breaks down into charcoal, gases, and smoke. Charcoal burns. Gases mostly burn. Smoke escapes. That smoke is wasted energy and creosote building up in your chimney. The rocket mass heater's J-tube changes everything. Horizontal feed forces air to flow in one direction. Vertical burn chamber creates intense draft. More oxygen reaches the fuel. The fire burns hotter, 900 to 100 degrees Celsius. At that temperature, everything combusts. Wood, gases, smoke. You're burning the byproducts of burning. The exhaust is nearly invisible. If you see smoke, you've done something wrong. What you see is heat shimmer, like distortion over asphalt in summer. And here's the critical part. That superheated exhaust doesn't go up and out. It travels horizontally through a mass bench made of cob, brick, stone, or clay. The mass is typically 500 to 2,000 pounds. As hot gases move through channels inside the mass, heat transfers into the material. The mass warms slowly. An hour of burning raises the surface temperature to 40 or 50 degrees Celsius. Warm to touch, not scalding. After the fire dies, that mass radiates heat for 12 to 24 hours. This is thermal battery technology. You're storing energy as heat in a medium that releases it slowly. Same principle as Korean Ondol floor heating for over 1,000 years. Same as Finnish masonry stoves, it works. Proven. And the fuel consumption is absurd. A conventional fireplace burns a cord per month. A rocket mass heater uses a quarter to a sixth of that. One cord every 4 to 6 months in cold climate. Not because the fire is weaker, because the system wastes almost nothing. The durability? No moving parts, no electronics, no gaskets that degrade. The thermal mass doesn't wear out. The J-tube can last decades. If something cracks, replace it with mud and brick. Systems built in the 1980s still operate. Your children could inherit this heater. So why isn't this code approved in every county? Why isn't Home Depot selling kits? 2 reasons, and neither is safety. The HVAC industry doesn't want you to heat your home once. They want you heating it every year, paying every season, servicing every breakdown. A $300 mass heater that lasts 50 years is a catastrophe for a contractor who sells $15,000 furnaces. Not unsafe, unprofitable. Here's the first barrier. Building codes. Rocket mass heaters aren't in the International Residential Code or the Uniform Mechanical Code. Not because they're dangerous, because they're site-built, not factory products. Code enforcement looks for UL listings, EPA certifications, manufacturer spec sheets. A mass heater doesn't have those. It's architecture, not an appliance. You're building it into the structure of your home, like a fireplace or a chimney. But the code says approved heating appliance, and mass heaters don't fit that category. So inspectors red flag them. Permits get denied. Insurance companies refuse coverage because there's no standardized testing data. This isn't about safety. Rocket mass heaters have been used in Korea, Finland, Russia, and China for centuries, under different names. The physics works. The problem is liability. If a product doesn't have a manufacturer to sue, insurance companies get nervous. And if homeowners can't get insurance, banks won't write mortgages. The entire housing finance system is built on standardized, replaceable components. A custom-built heating system breaks that model. Now let's talk economics. A gas furnace install costs $5,000 to $15,000 depending on size and complexity. The contractor makes money on the install. Then you've got annual maintenance contracts, $150 to $300 per year. Filter changes, inspections, cleaning. The furnace lasts 15 to 20 years, then it dies and you buy another one. Over 30 years, you're spending $20,000 to $25,000 on heating equipment alone, not counting fuel. A rocket mass heater costs $200 to $500 in materials if you build it yourself. Zero maintenance. No service contracts. No replacement cycle. It lasts 50 years, maybe longer. You're out of the market. Forever. You're not a customer. You're a threat. If everyone built mass heaters, the HVAC industry loses recurring revenue. Furnace manufacturers lose sales. Service companies lose contracts. Natural gas utilities lose customers because you're burning wood scraps instead of piped methane. The entire business model collapses, so the technology stays buried. Not illegal, just excluded. It's kept in permaculture forums, off-grid blogs, hobbyist communities. No marketing budget, no Home Depot aisle, no contractor network pushing it. You have to dig to find it. But here's the thing. Even the most efficient heater is useless if the building bleeds heat faster than you can generate it. That's where the second buried technology comes in. You don't have a heating problem. You have a heat loss problem. Every BTU you generate is racing to escape through your walls, windows, roof, and foundation. The most efficient heater in the world is useless if your building envelope bleeds heat faster than you can produce it. Here's what construction codes don't mandate. Heat escapes through three mechanisms: conduction, direct transfer through solid materials. Metal and wood conduct heat. Every stud in your wall is a thermal highway, carrying warmth from inside to outside. Convection, heat transfer through moving air. Every gap around a window, door, or electrical outlet creates airflow. Warm air escapes, cold air rushes in. Radiation, infrared energy passing through transparent materials. Single pane glass radiates heat like it's not even there. Standard residential construction in North America uses R13 to R19 wall insulation. R value measures resistance to heat flow. Higher is better. R13 means fiberglass bats between studs. It's cheap, it's code minimum, and it's a disaster. A typical house built to code loses 30 to 50% of its heat through air. Leaks alone before you even account for conduction through the walls. You're heating the outdoors. Now let's look at what's possible. The Passive House Standard, developed in Germany in the 1990s, targets R40 to R60 wall assemblies. That's triple to quadruple the insulation. Dense packed cellulose, mineral wool, or foam fills every cavity. External insulation wraps the structure to eliminate thermal bridging. The studs don't conduct heat out because they're buried inside the insulation layer. Airtightness is measured with a blower door test. A fan pressurizes the house to 50 pascals and measures leakage. Standard construction, 5 to 15 air changes per hour at that pressure. Passive House Standard, 0.6 air changes per hour. That's 10 to 25 times tighter. At that level of sealing, you've nearly eliminated convective losses. The building doesn't breathe unless you want it to through controlled ventilation. Windows are the weak point. Single pane glass is R1. Double pane with air gap is R2 to R3. Triple pane with argon or krypton fill and low emissivity coatings gets you to R7 to R10. That's a tenfold improvement. The glass reflects infrared back into the room instead of letting it radiate into the night. The result? Passive houses in Germany and Sweden maintain 20 degrees Celsius indoors with 10% of the heating energy a standard house requires. Some are heated entirely by body heat, appliances, and sunlight. The building is a thermos. Heat goes in and stays in. So why isn't this standard code? Why are builders still wrapping houses in R13 fiberglass when the science for R60 has existed since the 1970s? A house that doesn't need heating is a house that doesn't generate utility revenue. Building codes are minimums, not maximums. Guess who sets those minimums? Not that builders can't build to passive house standards. They won't. Here's how it works. Building codes in the United States are developed by the International Code Council. The members, representatives from construction trade associations, HVAC manufacturers, insulation companies, and building material suppliers. The people writing the standards are the same people profiting from mediocre efficiency. They set R13 as code minimum because that's the level where fiberglass bats sell in volume. Go higher, and you're cutting into their market dominance with competing materials like dense pack cellulose or mineral wool. Utility companies lobby hard against strict efficiency mandates. An energy-efficient home uses less electricity and gas. Lower consumption means lower revenue. Utilities are regulated monopolies with guaranteed rate of return models. Their profit is calculated as a percentage of capital expenditures. They make money by building infrastructure, power plants, pipelines. If every house was built to passive standards and energy demand dropped by 80%, utilities would lose billions in revenue and have no justification for infrastructure expansion. So they fund lobbying, groups that argue against aggressive efficiency codes, claiming they're too expensive and hurt affordability. Let's talk contractor economics. Super insulation adds $15,000 to $25,000 to the upfront construction cost of a house. That's triple stud walls, external rigid foam, high-performance windows, meticulous air sealing. The homeowner saves $2,000 to $3,000 per year on heating and cooling. 10-year payback, then pure profit. But here's the problem. The builder doesn't pay the utility bills. The homeowner does. The builder's incentive is to minimize construction cost and maximize sale price. Efficiency improvements don't show up in appraisals the way granite countertops do. Banks don't adjust mortgage terms for energy performance. So builders cut corners on insulation because the market doesn't reward them for doing it right. Developers building tract housing operate on razor-thin margins. They're competing on price. Every dollar spent on insulation is a dollar not spent on curb appeal or square footage. R13 is code minimum. R60 costs triple. Guess which one gets built? The system isn't designed to create efficient buildings. It's designed to generate recurring energy sales, ongoing HVAC service contracts, and planned obsolescence in building materials. You've got heat generation that uses a quarter of the fuel. You've got insulation that cuts loss by 80%. But in a prolonged collapse, even firewood becomes scarce. That's where the third technology makes you truly independent. Wood runs out. Propane stops being delivered. But organic waste never stops. You can heat your home by burning garbage. Not trash incineration. Chemical conversion. Start with alcohol stoves. Denatured ethanol, or methanol, burns clean, produces high heat output, and is safe indoors with proper ventilation. A simple alcohol burner made from a soda can generates enough heat for cooking or supplemental warmth. The fuel is liquid, stores indefinitely, and doesn't produce smoke or soot when it burns. But here's the critical part. You can make it. Fermentation. Take food scraps, overripe fruit, grains, sugar. Add water and yeast. The yeast consumes the sugars and produces ethanol and carbon dioxide. After a week or two, you've got a weak alcohol solution, maybe 10 to 15% ethanol. Distill it. Heat the mixture, capture the vapor, condense it back to liquid. Ethanol boils at 78 degrees Celsius, water at 100. You can separate them. What comes out is 90 to 95% pure ethanol. That's fuel. Energy density is 21 megajoules per liter, comparable to kerosene. Now let's talk biogas. Anaerobic digestion. Bacteria break down organic matter in the absence of oxygen and produce methane. It's the same process that creates natural gas in landfills, but you can do it at home. A 5-gallon bucket digester filled with food waste, manure, or plant material, produces enough methane for 1 to 2 hours of cooking or heating per day. The gas is 55 to 70% methane, 30 to 45% carbon dioxide. It burns. Energy density is 35 megajoules per cubic meter. 1 kilogram of food waste yields roughly 0.3 cubic meters of biogas. The system is simple. Sealed container. Inlet for organic material, outlet for gas, outlet for spent slurry. Keep it warm, 25 to 35 degrees Celsius. The bacteria do the rest. Rural communities in India and China have been using biogas digesters for decades. It works. Wood gasification is the third option. Pyrolysis. You're not burning wood directly. You're heating it in a low-oxygen environment until it breaks down into charcoal and combustible gases. Syngas. Carbon monoxide and hydrogen. The gases burn hotter and cleaner than wood smoke. A Tia-Lud stove, top-lit updraft design, does this efficiently. Load it with twigs, wood chips, or pellets. Light the top. As the fire burns down, it creates a gasification zone below. Minimal smoke. High heat. You can build one for $20 in materials. The pattern is the same. You're converting waste, scraps, and materials nobody wants into usable energy. No supply chain. No middleman. Just chemistry. 3 technologies. Heat generation that uses a quarter of the fuel. Insulation that cuts loss by 80%. Fuel you produce from waste. And the energy industry has spent 50 years making sure you never connect these dots. Let's step back. 3 technologies. Same burial strategy. Not because they don't work, because they work too well. The system doesn't want you warm. It wants you paying. Rocket mass heaters eliminate HVAC service contracts. No annual maintenance. No technician visits. No filter replacements. No 15-year replacement cycle. You build it once and it lasts half a century. That's 50 years of lost revenue for contractors, furnace manufacturers, and natural gas utilities. Super insulation eliminates high utility bills. A house built to passive standards uses 80 to 90% less energy than code minimum. If every new home was built this way, demand for electricity and natural gas would crater. Utility companies would lose billions. Power plants would sit idle. The entire energy distribution infrastructure would be overbuilt and underutilized. Waste-to-fuel systems eliminate propane deliveries and firewood purchases. You're converting garbage, food scraps, and yard waste into combustible energy. No supply chain. No monthly deliveries. No dependence on fossil fuel markets. You're closed loop. Here's the economic threat. Each technology removes you from a dependency cycle. Combine all 3 and you've achieved thermal sovereignty. Heat generation that uses a quarter of the fuel. Insulation that retains 80% of that heat. Fuel you produce from waste. After the initial build cost of $5,000 to $8,000, your heating expenses drop to nearly zero. Over 30 years, conventional heating costs $50,000 to $70,000. You've saved $45,000 to $65,000. You're out of the market. Permanently, and that's the problem. The modern economy isn't built on solving problems. It's built on managing them. Temporary relief that requires renewal. Subscription models. Planned obsolescence. A customer who solves their problem permanently is a customer you lose forever. So the industry response isn't to ban these technologies. That would be too obvious. The strategy is exclusion. Keep them out of building codes. Don't offer UL certifications. Refuse insurance coverage. Exclude them from trade school curricula. Don't stock the components at retail chains. Spend $0 marketing them. Relegate the information to permaculture forums, off-grid blogs, hobbyist communities. Make people dig to find it. Meanwhile, Spend billions advertising furnaces, insulation products, and propane service plans. Sponsor HVAC training programs. Fund lobbying groups that argue against aggressive efficiency mandates. The message is clear. Keep buying. Keep upgrading. Stay in the cycle. This isn't conspiracy theory. It's business model analysis. And in World War III, when supply chains collapse and fuel deliveries stop, business models don't matter. Physics does. Thermodynamics doesn't care about quarterly earnings. So here's what it comes down to. You can wait for the grid to fail and freeze. Or you can build thermal independence while the hardware stores are still open. Thermal sovereignty isn't luck. It's physics plus preparation. 3 layers. Efficient generation, minimal loss, independent fuel. You build them now, before the store's empty, before the supply chains break, before the war turns your neighborhood into a frozen wasteland. Start with insulation. Seal every air leak in your house. Caulk windows. Weather strip doors. Foam seal electrical boxes and pipe penetrations. Add insulation wherever you can. Attic, walls, crawl space. Dense pack cellulose cost $1 to $2 per square foot installed. You can DIY it for less. Upgrading from R13 to R40 in a 4,500 square foot house costs $3,000 to $5,000. That's your shell, your thermal envelope. Next, build backup combustion systems. A simple alcohol stove costs $5 in materials. A TLUD gasifier stove, $20 to $50 depending on design. Start fermenting. Get a small still. Learn the chemistry. Set up a 5-gallon biogas digester, if you've got space and organic waste. These are skills, not products. No one can repossess knowledge. Then plan your mass heater. Research designs, source materials. Cob, brick, and clay are cheap. A DIY rocket mass heater costs $200 to $500. If you're not ready to build inside your house, build one in a workshop or outbuilding first. Learn how it works. Dial in the fuel feed rate. Understand the thermal mass behavior. When you're confident, integrate it into your living space. Total cost for all 3 layers, $3,500 to $5,500. Compare that to 30 years of furnace payments, utility bills, and propane deliveries. You're looking at $50,000 to $70,000 in conventional heating costs. You've just bought yourself independence for 1/10 the price. This isn't prepping. It's engineering. And if conflict starts, you've got 72 hours before panic buying strips the hardware stores. Maybe less. The window closes fast. Share this. Build with your neighbors. Create local networks of thermal independence. The collapse won't be survived by individuals. It'll be survived by communities that figured out how to stay warm when the system failed. You're not waiting for permission. You're building exits. Stay warm. Stay independent. Thermodynamics doesn't negotiate.